Today on Capeggi's Corner, we're going to look at the rational zero theorem. So what that states is if I have a polynomial function, then every rational zero comes in the form of P over Q. So what that means is P is the factor of the constant term, and Q is our denominator. That's a factor of the leading coefficient. So the example they give us is if we have 4 over 3 as an answer, 4 is a factor of negative 40, which is our constant, and 3 is a factor of 6, which is our leading coefficient. Now, one thing to build off of their corollary is if the leading coefficient is a 1 and our constant is not a 0, then any rational zeros must be factors of the constant term, because if we have our Q value is equal to 1, then it doesn't matter if our P value is 4 or 6. We would have to have 4 over 1 or 6 over 1, which would just come back to basically the factors of P. All right, let's try some. Okay, just as a reminder, rational numbers are real numbers, and they can be expressed in a fraction where A and B are integers and B is not a 0. Okay, so we're asking to list all the possible rational zeros for the function. Okay, so first of all, remember we're going to have P over Q and our factors of 12. 12 and 1, 6 and 2, 4 and 3. This is 1, right? Our coefficient there is 1. So this is all our P values here. We have 1 times 1, that's actually our Q value, so that's going to be our denominator. Now remember, our factors, like factors of 1 could be positive 12 and positive 1, or negative 12 and negative 1. We're not going to list them separately here, but we are going to keep that in mind when we list them as our final answer for possible zeros. Okay, so a lot of times we like to go in order, so I'll start with 1. It's going to be over 1, so it's just going to be factors of P. I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Okay, they're all possible rational zeros. It doesn't mean they are, but it means they're possible ones. Okay, let's take a look at our next one. A little bit more involved because of the fact that our Q value here, we can have 4 and 1, and we can also have 2 and 2. So that's our Q values. Our P values, factors of 16, so I have 16 and 1, 8 and 2, 4 and 4. Okay, so now let's see what we have. Remember that our P is over Q. So we'll start with let's do over 1, right? So I'm going to have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, because they're all factors of P over 1. Okay, now we're going to do these factors over 2. Okay, so now we're going to work with our 2's. So we have, if I start with 1, I could have plus or minus 1/2, right? I could also have, if I go to 2, look at this, if I go 2 over 2, that equals to 1. We already have 1, so we don't need to include that. Same thing if I go 4 over 2, that's 2. So I don't need that one. I already have that one. And the same thing if I use 8. 8 over 2 is 4, have that one. 16 over 2 is 8, so I have that one as well. Okay, so the last set I'm going to look at is look at 4. Okay, so I have plus or minus, right, 1/4. If I do 2, right, 2 over 4 is equal to 1/2. I already have that one. 4 is 4 over 4, have that one. 8 over 4 is 2. 16 over 4 is 4, so we have that one. So that's our final answer right there. Okay, now we're going to look at find all the zeros of the given polynomial. We're going to use synthetic division. Okay, I'm actually going to start with number 4 first. So in using synthetic division, we don't know which number is going to go in the box. We're going to talk about that in just a minute. So we have 1, -1, -11, -1, and -12. Okay, now remember, we're going to have 4 solutions because our highest power is 4. Possible options we have, right? We have 12 and 1, we have 6 and 2, and we have 4 and 3. I'm going to slide this down, get that ready to go. Now, it really is just a guess and check. So in this first one, I'm not going to do it correctly. I'm going to just do one that is not going to work. So I'm going to try 2. And again, it really is guess and check. How do I know that? Because I did this problem already before I started the video. So I'm going to bring this down. So I have 2. That gives me, combined, I get 1. 2, and I get negative 9. And then 2 times 9 gives me negative 18. Now, at this point, and this is where with practice you'll get better, I can see that this is, remember, if I want a 0, I need my remainder to be 0. I can see if I do this, I'm going to get negative 19, and I already see I'm well kind of above my head here. That's not going to be 0, so I know 2 is not an option. So as soon as you can kind of figure out that that remainder is not going to be 0, you can stop. You don't necessarily need to do the whole thing. Okay, let's try 4 as an option. So I'm going to use 4 in my box. And again, I'm going to set up my synthetic division. Bring down my 1, I get 1, then I have 4, combine, I get 3, 12, 4, 3, and I get positive 12, so I have 0, which is what I want. Okay, so I know that 4 is one of the zeros. Now, I'm going to have to factor like I've done this in the past to find my other zeros. So I'm going to rewrite this, and I have x to the third plus 3x squared plus x plus 3. That equals 0. Okay, so I have 4 terms, so I know I'm going to use factor by grouping. So I have x squared is my greatest common factor, my first group, and I get x plus 3. My second group, I'm going to have a 1 there, so I can have that x plus 3 in parentheses. My greatest common factor is x plus 3. And then I'm left with x squared plus 1 is equal to 0. So now I'm going to solve. So I have x plus 3 is equal to 0. X squared plus 1 is equal to 0. So x is equal to negative 3. Bring that 1 to the other side. And remember, this is x is equal to plus or minus I. So my final answer, my zeros are, don't forget the first one. I have 4 that I used in synthetic division, negative 3, and then I have plus or minus I. They're all my possible zeros. They're actually all my zeros. My possible zeros are up here. Okay, so there are 4 answers there. And then, like you said, when we started, I know I need to have 4 answers because my highest power is to a 4. All right, let's try one more for today. So again, for 36, I have lots of options here. I have 36 and 1. I have 8 and 2. I have 12 and 3. I have 9 and 4, and I have 6 and 6. So that's all my P values. My Q values, I have 5 and 1. Okay, so I have lots of possible zeros there. After playing around with it, I was able to come up with the fact that 2 will work out for me. So I have 5, negative 8, positive 41, negative 72, and negative 36. So remember, I'm looking for a remainder of 0. So I get 5, and I get 10 here. Gives me 2, 4, 45. I have 90 there. I have positive 18, positive 36, so I'm good. Okay, so again, now I have to factor. So I have 5x to the third plus 2x squared plus 45x plus 18 is equal to 0. Again, 4 terms, so I can only use factor by grouping. So I'm going to take it x squared, and I'm left with 5x plus 2 plus 9, and I'm also left with 5x plus 2. My greatest common factor is 5x plus 2, and I'm left with x squared plus 9. That equals to 0. So I have 5x plus 2 is equal to 0. X squared plus 9 is equal to 0. So x is equal to negative 2/5. X squared is equal to negative 9. Take the square root of both sides. So x is equal to plus or minus 3i. Okay, so my final answer here, again, I have to grab that 0 from the beginning that I used in synthetic division to negative 2/5, and then plus or minus 3i. They are my 4 solutions. Okay, great job today. Thanks so much for stopping by.